Hey everybody, hope you guys are doing okay. All right, let's get into your science lesson here. So we're going to talk about static electricity and charge. We're getting into a new unit here. So first off, I posted this as a resource in your Google class. I'd like you guys to take a watch, take a look at it. It's a Bill Nye video. It's 22 minutes long, and I got a sheet you can fill out as you watch. I think it's a really good video. So take a look at that before you get into this. So static charge. So static charge happens in our everyday life. So when lightning strikes, static cling with clothes. If you ever go to the dryer and your socks or something are stuck to your shirts and stuff, that's from static charge. When you shock someone when you're wearing socks and when you're walking on carpet, that's all from static charge. So electrons, why does that happen? Electrons can build up on surfaces and they create that electric charge. The opposite charges attract and similar charges repel each other. So if your socks are sticking to something, that's because it's got opposite charges to different parts of the clothing. That's just from friction from being in the dryer. So protons are positively charged. You guys know this. You were just doing some chemistry. And in the center of the atom, whereas the electron is on the outside and can move more freely within the substance or object that you got. So static electricity. So static electricity is a stationary electric charge. So if you watch that Bill Nye video, you'll know that static kind of means stay. That's where that word came from. And electricity comes from the word electron. So it's stationary means not moving. Electric charge. That's how those words came to be. So static electricity is a stationary electric charge that causes sparks or zaps. The buildup of charge leads to the electrons jumping to a different object. So I included this picture here just because it kind of shows how lightning works. So when there's large clouds that are rubbing against each other with friction, there's a buildup of charge often in different parts of the cloud. And so if it gets to be enough electrons in the cloud, then a zap of lightning will actually happen between the cloud and the ground, the positive or the neutral ground. So that's how that happens. So the law of electric charges. So most objects are neutral or uncharged because they have a similar number of positive and negative charges. So the law of electric charges says that like charges repel each other and unlike charges attract each other. So what does that mean? That means negative and positively charged objects will attract, and positive will repel, negative and negative will repel, and neutral objects attract both positively and negatively charged objects. Now, we'll see in a couple slides here why that happens, but that's because when you bring a object with a positive or negative charge near another object, it will bring the opposite charged part of that object closer to it and push away. It seems abstract, but I'll show you in a little experiment that we're going to do. So this is the experiment. Try it yourself. Grab a comb, run it through your hair quickly several times. Hold it next to a slow stream of water, and the slower the better if you just get a slow, steady stream from the tap and see what happens. So if you're on this video, I just want you to pause it and go do that. Take 2 minutes to go do it. It's kind of neat. So the comb should have collected loosely held electrons from your hair through friction when you rubbed it. I tried it too, and it works even with short hair, so everybody should be able to do it. So when you place the comb next to the water stream, the water bends towards the comb because the electrons from the negatively charged comb are attracted to the neutrally charged stream. So I said I'd explain why that happens. So if you have a negatively charged comb on the left there, that's from the rubbing your hair with the comb, running it through your hair. You're collecting the electrons. You're moving it closer to the neutral water stream. So you can see the water stream on the picture on the left there. It has positive and negative symbols there just to show that it's neutral. And when you move it closer, so the picture on the right, you'll see that the electrons are within the water are pushed to the far side. They're repelled from the electrons in the comb. And then the positive charged protons are kind of right there. They're attracted to the electrons in the comb. So that's why the water bends towards the comb, and that's why neutrally charged substances or objects, like things that have very negative or very positive charges, that's why they're attracted. So again, when we talk about charge, so positive charges, which come from protons, cannot move within a substance. Only the loosely held electrons can move freely within a substance or material. So if electrons are gained by a material or substance, that means they're getting more negative and they're getting a larger negative charge. If electrons are lost, that's kind of like subtracting a negative, you gain a positive charge. So in that experiment that we did, when you ran the comb through your hair in the last experiment, the comb picked up electrons from your hair by friction and became more negatively charged. Your hair lost electrons, so it's kind of subtracting negative charge, and so it became more positively charged. So just a quick summary from the video that we had watched and then the little experiment that we did and running through this PowerPoint. So charge is opposite charges attract, the same charges repel, and both the negative and positive charges attract to neutrally charged objects. And remember that charge comes from the protons and the electrons from the atoms. So static electricity, which is the zap or the spark, is caused by a buildup of electrons which jump to a positively charged object. That stream of electrons, the zap or the spark, that's what it is. It's electrons. It's not protons or neutrons moving. It's going to be the stream of electrons only moving because they're so loosely held and they're on the outside of the atom. They're more loosely held than the nucleus, which has the protons and neutrons. So yeah, only electrons move. If electrons are gained by an object, it becomes negatively charged, which we just said. And if electrons are lost by an object, it becomes positively charged. All right, so these are the kind of things I want you to get from this lesson. We're going to be building on this, so I'd like you to watch that Bill Nye video if you haven't already. Yeah, and I'll talk to you guys tomorrow.